Good afternoon. I'm Dr. Janardhana Rao. We're discussing about process management. So far, we have discussed CPU scheduling algorithms, what is process states, how the process is being taken place from one state to another state. We discussed all these things. Today, we're discussing about critical section and synchronization and semaphores. So, in the previous slide, we discussed about what is semaphore, what is critical section, and what is Peterson critical section problem and solution. And today we are going to discuss this some of the classical problems of synchronization, some of the classical problems depicting flaws of process synchronization in systems where cooperating processes are present. So, as we discussed, if one process is running in the common area or CPU or shared memory, other process should not disturb that one. So there will be lock on this CPU, or rather you can say on common area. Another process cannot enter in this one. So based on this one, we have seen what is semaphore. So by using the semaphore, we got some classical problems and solutions, and we'll discuss that one. So bounded buffer problem, a readers and writers problem, Daring philosopher problem. This is the main three problem occur. The problem is in synchronization. These problems solved by using the semaphore variables. So we'll see one by one. So classical problems in synchronization, bounded buffer, bounded buffer problem. The buffer pool has a maximum size. The problem is often called the bounded buffer problem. This problem is generalized in terms of producer-consumer problem, where a finite buffer pool is used to exchange messages between producer and consumer process. Solution to this problem is creating two counting semaphores, full and empty, to keep track of the current number of full and empty buffers respectively. In this producers, mainly producers produces a product and consumer consumes a product, but both can use one of the containers in time. The main complexity of this problem is that we must have to maintain the count for both empty and full containers that are available. So if you look at this classical example, so the consumer and producer. So once producer produces a product, one product, and will keep in the common area. So when producer preparing and producing some item and keeping this one, the consumer till that time he will be in the sleeping mode. So he will wake up this consumer and producer produces and he will keep the item in the buffer and the consumer will consume that item. So here we will see what is this producer consumer problem and how the synchronization takes place. So at a time only one can use this common area. So it means that this bounded buffer problem, in this one, this is a simple pseudocode for the producer-consumer problem. Produce an item and in next and wait empty and wait mutex. Add next to buffer. A signal mutex signal while it is a continuous loop. So if you look at this one, producer produces the items and add to the next. So if it is empty, he will add it. So he will wake up the consumer. This is consumer part. Consumer, he will wake up by giving the signal that is full. So now consumer will remove the item from the buffer to next. So that is producer produces and handover are put in the common area. So consumer will consume it. So there are two signals. One is empty and one is full. Empty means when the buffer is empty means then there is no item available for the producer or consumer to consume the item. So in meantime, so when producer producing the item, the consumer will go in the sleep. That is when the item is not available. So you can see that producer will sleep when buffer is full. So consumer will be waked up by sending the signal full. Then consumer will get the item from the buffer and he will consume it. Till that time, the producer will be in the sleeping mode. So that what's at a time only one will use this common area. That is where it is a CPU or a shared memory or anything. Only one can access at a time. So this is simple producer consumer problem. So another one is the readers writers problem. In this one, unless write is completed, reader cannot enter. So in this problem, there are some processes called readers that only read the shared data and never change it. And there are other processes like writers who may change the data in addition to reading or instead of reading it. So there are readers and writers problem. So unless write is completed, reader cannot enter, a reader cannot do anything. There are various types of readers writers problems, most centered on relative priorities of readers and writers. The main complexity with this problem is from allowing more than one reader to access the data at the same time. So two possible. So no reader is kept waiting unless a writer holds the lock. So see, once this is your common area. So once the write is completed, reader cannot enter. There is a lock on the shared memory. So you cannot enter. So no reader is kept waiting unless a writer holds the lock. Once it is not locking, once is writing something in the common area, shared area, and if it is taking more time, this is complexity. So contradiction. The readers have to have precedence. If a writer is waiting for access, no new reader gains access, no reader gains. So this is another one is Danning philosopher problem. In the Danning philosopher problem, so the Danning philosopher problem involves the allocation of limited resources into a group of processes in a deadlock-free and starvation-free manner. See, as we know that our operating system is a resource allocation allocator. So it will make sure that systems will not get hanged up. Some process holding some resources and some process holding some resources. Unless one first process releases the resources, other second process cannot utilize this one. So this is we will discuss the deadlock situation further in coming lectures. So the OS is one which reallocate or allocate the limited resources to a group of processes in a deadlock-free and starvation-free manner. There are just we'll see one example. They just you look at this one. This is a Danning philosophers. This is a philosophers. They're thinking, and whenever they're feel hungry, they will eat it. So this is there are 5 processor. You can say philosophers sitting in the dining table. They'll be thinking something. Whenever when one feeling hungry, so there is a condition, and as for the condition, he has to take the dinner. So dinner or anything. So 5 philosophers sitting at a round table to eat. So each one has to get a plate and one chopstick at the right side of each plate. This is a condition. To start eating, each of them need a plate and 2 chopsticks. One stick already there. So, thus, clearly there will be a deadlock and starvation because of the limited number of chopsticks. So, this can be solved by either by allow only 4 philosophers to agree at a time. So, allow pick up only if both chopsticks are available, or philosophers always picks up left chopstick first, then philosopher always first. This is for odd and even philosophers. Pick up the right chopstick first. So these are the conditions. So if you make an analogy between this Danning philosophers and our processes, So we can allot the resources to the processes so that system will not get hanged up, or there will not be any deadlock free situation. So this is dining philosophers synchronization. In this one, so there are 5 philosophers sitting around table in which there are 5 chopsticks, forks are kept them, and bowl of rice in the center. When a philosopher wants to eat, he uses 2 chopsticks, one from the left and one from the right. When a philosopher wants to think, he keeps down and both chopsticks at their original place. So this is the conditions. This condition is similar to our process management and processes. So whenever the process want to executing, use it resources like your CPU or shared memory, anything. That time, this is a similarity we will take consideration. This is dining philosophers problem. So another one is monitors. This monitor is a program. The monitor is one of the ways to achieve process synchronization. The monitor is supported by programming languages to achieve mutual exclusion between processes. For example, Java synchronization methods. Java provides wait and notify constructs. So in other words, monitors are defined as a construct of programming language which helps in controlling shared data access. The monitor is a module or a package which encapsulates shared data structure, procedures, and synchronization between the construct procedure invocation. So as we have seen, the synchronization is very important one. So we have seen the classical problems. One is dining philosophers, readers, writers, and bounded buffer. That is your producer consumers. Apart from this, monitor is another technique. This is monitor is defined as a construct programming languages. The monitor is a modular package which can encapsulate shared data structure, procedures, and the synchronization between the construct and procedure invocations. So we'll see what is the monitor characteristics. So inside the monitors, we can only execute one process at a time. This means this is a program. Monitors are the group of procedures and conditions variables that are merged together in a special type of module. If the process is running outside the monitor, then it cannot access the monitor's internal variable, but a process can call the procedures of the monitor. Monitors often high-level synchronization. There is only one process that can activate at the time of inside the monitor. So if you look at this example, this is a program or package syntax for monitor. So monitor, this is monitor demo. Name of the monitor, variables, conditions variable, procedure 1, procedure 2. So again it will have two signals, A dot wait and A dot signal. The process that performs wait operation and the condition of the variables are suspended and locate the suspended process in a block queue of that condition variable. Signal operation. So A dot signal is if a signal operation is performed by the process on the condition variable, then the chance is provided to this one of the blocked processes. So condition variables are wait and signal. There are two types of operations can be performed on the condition variable of the monitor, wait and signal. So monitor is also is a technique, or you can say similar to semaphores to control the synchronization or to control the critical section problem or to solve the critical section problem. In this also there are two types of signals, wait and signal. So wait is the one which keeps the processes outside the critical section, and whenever the work is completed by the one process, so automatically that signal will be sent to the other processes. So other processes will be activated and they will make use of this shared memory or shared documents. Suppose there are two conditions variables, condition A and B, declaring variables. So monitor advantage of the monitors. It makes the parallel programming easy, and it monitors if monitors are used, then there is less error prone as compared to these semaphores. So disadvantage of monitor. So monitors have to be implemented as a part of the programming languages, and the compiler must generate code for them. This gives the compiler the additional burden of having to know what operating system facilities are available to control access to critical sections to construct processes, to concurrent processes. So some languages that do support monitor are Java, C Sharp, Visual Basic, and concurrent Euclid. So monitor is also a technique like semaphores, but it is a package, and at the same time, semaphore is a problem. It is written in the program which is kept in the operating system to control the concurrent synchronization. So far, we have discussed about critical section problems and monitors and semaphores and classical problems of synchronization. This these are so important. This is readers. This is bounded buffer, readers and writers, and dining philosophers problem. So, in the coming sessions, we will discuss about memory management and what are the um, programs available in the OS for the proper memory management. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.